Okay, so we're going to take the time to review some 6th and 7th grade concepts regarding inequalities before we dive into the difficult stuff that comes in Algebra 1. So we're going to start with graphing, and really the easiest way to graph an inequality is really to truly understand what it means. So when we read this first problem, x is greater than 9, what that means is that the value of x that we don't know could be any number bigger than 9. Okay, so if we think about some numbers that could be placed in where that x is, we could have numbers like 10, because that's bigger than 9. You could have numbers like 24. You could have 3,814. Or you could have maybe just 9.001, right? As long as the number is bigger than 9. Well, instead of making this list for people of all these different numbers that are bigger than 9, we could just show it on a graph. So I'm going to mark 9 on the graph. I didn't count that out. I just picked a spot and called it 9. And then I'm going to show from 9, any number that's to the right on the number line will work as a solution for x. That shaded arrow represents the x, okay? Because it's marking off 10, 11, 12, 13, as well as the in-betweens like 11.5 and 12.684 repeating, etc. Now, notice I circled the 9 with an open circle, okay? If I think about, again, numbers that will work for that x, if I put a 9 there, is 9 greater than 9? Well, no, right? 9 is not greater than 9. So I cannot have a closed circle on the 9. Leaving it open like this shows that you can't actually use the 9. Okay? So let's try this again. If we have y is less than or equal to 12, well, again, what numbers will work for y? Things like 11, things like -4, things like 11.894, random numbers as long as they are less than or equal to 12. So I'm going to mark 12 on my number line, draw my circle, and instead of listing out the thousands of numbers, millions of numbers, trillions, infinite number of numbers that are less than 12, I'm just going to show on an arrow that it's all the numbers less than to the left from that 12. Now what's different about this one is that 12 is less than or equal to 12. So I actually want to color in my circle here to show that 12 can be used as a value for y. Okay, so just a quick little side note. These two symbols, open circle. These two symbols, closed circle. Okay? So let's get a little quicker. M is less than -4. So I'm going to mark -4 here, open circle, less than. G is greater than or equal to 2. Mark my 2, closed circle, G is greater than. Okay? The difference in this right-hand side is that all of our variables are on the right-hand side of the inequality. You do not have to rewrite them. You can, but you do not have to. You can actually, again, just think about what this means. Well, what are some values that will work for x here? Well, things like 5, right? 4 is less than 5. Okay, or what if we did 12? 4 is less than 12, or 349. Or even just 4.2, right? All those numbers are going to be bigger than the 4. So to show those on my number line, mark the 4, open circle. I'm listing numbers that are bigger than that 4, right? If you read this inequality, instead of from left to right, but you read it from the variable, it starts to make sense. X is greater than the 4. When you read it that way, it makes sense why you shade to the right. Okay? So again, on this next one, x is greater than or equal to the 12. When you read it that way and you mark your 12 with your closed circle, makes sense that you would go to the right because x is greater than or equal to that 12. So the next one, again, reading from the y. Y is less than 14. So I've got my 14, open circle, but now I'm going to go down. Okay, because again, if I think about numbers that will work here, it's things like 12, -9, 1, 0, etc. Okay, so last one, again, I'm going to mark -280. Close circle this time, and h is again less than or equal to. Okay, forgot to change my colors in between each one. Whoops. All right, so now let's recap how to solve. It's very similar to solving just an equation. Just one little detail is a little bit different. So number one, we're going to start with all the same steps. I'm going to subtract my constant. So 4d is less than or equal to 16. Divide by my coefficient. D is less than or equal to 4. Nothing's different there. Same as an equation. Number two, it's going to start the same. Add my constant of 2. But here's where it changes. When I divide both sides by my -5, I have to flip the inequality symbol, okay? This little step right here of dividing by a -5 flips the symbol around the other direction for my answer. So x is actually greater than -2. Hopefully you learned that last year, the year before, and got a good explanation for it. If you want the explanation of why that is, feel free to stop by sometime and I'll explain it. For purposes of this video, we're going to move right past it, but there is an explanation as to why that works, why we have to do that. We're just not going to explain it here. Okay, so moving on to number 3, I'm going to add 3 to both sides. I'm going to divide by 5. Now in this case, do I need to, do I need to flip my inequality symbol? Well, no, because again, what I'm dividing by is not negative. That is a +5 in both cases. So I'm going to leave the inequality symbol the exact way that it was. M is greater than -3. Okay, so number 4, same story, subtract your constant. Divide by -3. So in this case, do I flip my symbol? Yes, because what I divided by is a negative. Number 5, my variable's over here this time. Add the constant. Divide by the coefficient. And we're done. And then number 6, last one, subtract the constant. Divide by the coefficient. Not going to flip my sign here because what I divided by here was not negative. So -2 is less than or equal to h. Okay? All right, there are a few more problems you can practice on here and graph, as well as an entire separate practice page that you're welcome to work through as a review. Let your teacher know if you have any questions. We'd be more than willing to help you out. Hopefully this helps.